With the end of the 2010s behind us now, I wanted to take a look back at the accomplishments during that exciting time of space exploration and knowledge of space in general. And I wanted to give you guys what I think my top 10 things are. Now, we saw some things that were pretty sad, such as the last shuttle launch, and we saw some things that are pretty exciting. A decade ago, small satellites were practically unknown. They were kind of a niche thing. They were in the realm of universities. You had some small satellite constellations that were out there, the largest of which I think was Irridium, that had less than 100 satellites, but it was the only really, truly large one. And they had a couple of other ones that had in the dozens of satellite realm, but nothing really huge. Well, during this last decade, Irridium launched another batch of, I think, 77 satellites. We have many other providers of satellites that are out there. We have at least 3 private companies that have a constellation of at least 50 small satellites operating, which is amazing. These things have really started to take a life of their own, to the point where NASA's building small satellites and sending them to Mars, where we have a small satellite launch company, Rocket Lab, that they're just in the business of launching small satellites, and they're able to do stuff. It's really cool. Overall, these small satellites are starting to do some really pretty amazing stuff, and I look forward to seeing more in the future. It's really cool that this stuff is starting to really come to fruition in these days. When I was a university student, we built a couple of CubeSats, these little itty-bitty thing. A CubeSat, by that definition, was what's called today a 1U CubeSat, a 10-centimeter cubed small satellite, and this is just kind of an experiment, but we're starting to see some of these launched by some real companies, doing stuff like testing solar sails in the case of Planetary Society, testing imaging systems where they're imaging the Earth, and all kinds of really neat stuff. And it's pretty neat overall. I look forward to seeing more. Number 9, we're back on the moon. Now, this seems a little bit crazy to put on the list of major accomplishments, but in 1976, we launched our last mission to even attempt to soft land on the surface of the moon, which was a unmanned probe that the Soviet Union sent, Luna 14, to collect a small amount of dirt, send it back to Earth, so that way they could get an understanding of what the moon is made out of. Well, we finally have returned to the moon. The Chinese have launched 2 landers during the 2010s, the Chang'e 3 and 4. Chang'e 4 landed on the far side of the moon, which is really exciting, the first time that anybody has done a soft landing on that far side of the moon. And moreover, we're really starting to talk seriously about humans getting back to the moon. The Artemis program in the United States aims to bring astronauts to the moon by 2024. Do I think they'll make it by that day? Not really, but it's still a step forward, and it's the closest date to sending humans back to the moon that we've had since the Apollo program. So I'm really excited to see where that goes, and hopefully we'll find out a lot more here soon. While we've been detecting exoplanets for 20 to 30 years, we made a number of important leaps forward in our ability to understand this. We've launched 2 major satellites during this case that were able to point and look at a patch of the sky and try to understand what's there, looking for small dips in the brightness so that they could actually detect planets. And we've been able to find a huge number of these planets. The number of discovered exoplanets has gone up so much. I'll just post a chart here that shows how many more exoplanets we know about now than we did in the past. And this has allowed us to do some characterization. We can understand roughly the size and the distance to their host star that they are, and get some idea of the trends. Now, we still can't see very many really, really small planets, such as Earth. But we're starting to get there, and every year it seems we're getting some new discovery. We're able to know now for sure that there's water in the atmosphere of exoplanets. And a lot of really neat stuff is out there. So I look forward to hearing more, and hopefully this decade will give us even more on this great account. commercial missions to the International Space Station. Now, this had been a little bit of a pipe dream in the 20-aughts that we were hoping to be able to send commercial missions to the space station, to bring astronauts there, to bring cargo there. And this was pitched as a replacement to the space shuttle that was retired at the beginning part of this decade. Well, it took them a little while to do this, but we were able to do commercial cargo missions to the International Space Station. To date, there's been something like 24 of them, roughly. All have happened in the 2010s. The only real capability to bring payload back from the International Space Station now comes in the form of the Dragon capsule. Soyuz can bring a little bit back, but the Dragon can bring a lot more. And this is a completely commercial opportunity. This wasn't even something that NASA asked for, but SpaceX decided that they wanted to provide it, and as a result, we're able to get some science experiments back from the International Space Station that we wouldn't otherwise be able to. So overall, it's pretty neat, and it's good to see progress being made on this front. We also saw towards the end of the 2010s the launch of commercial crew missions to the International Space Station. The Dragon mission, which was completely successful, and the Boeing Starliner mission, which was not completely successful, but still managed to demonstrate that it's safe. And hopefully we can actually launch real humans on board in this coming year, and it'll be a really exciting time to be able to launch American astronauts from American itself. Let's look forward to what's coming next. For the first time in our existence, we have space probes that are beyond the reach of the sun and everything but really gravity. The 2 Voyager missions that were launched to explore the outer planets have now reached into the outermost parts of the solar system. They're able to characterize things, and they know now for a fact that the solar wind is no longer the dominant force in the fields that they're seeing. They've reached the interstellar domain, and that's one very common definition of interstellar space. Now, the sun is still by far the biggest gravitational source they're exerting, and they're going to go through the Oort cloud that has a number of different objects that are gravitationally bound to the sun that we haven't actually seen yet, but it's there and they're making some progress, and this is a very big step forward for humanity to be able to make it here to the outer parts of the solar system. We were able to successfully image a black hole. Now, this is something I didn't think was going to happen in my lifetime. How do you image something that can't be seen? Well, there's a cloud of dust that circles around a black hole, and up until the very point of the event horizon, you'll see some of this gas there. And because it's moving so fast, it's emitting light and X-rays. So we're able to see this using the very specific type of equipment. And we were able to do that during this last decade. The way that we did this was by using a number of radio telescopes pointing at the same object in the sky, spread all over the world, watching this point as the Earth rotated. And as such, we're able to construct an image and produce an image of a black hole. Really, really neat advance, and hopefully we'll be able to see a lot more of that in the coming decade. But still, we were able to visually see one of these black holes and to confirm that it meets the basic ideas that we had behind a black hole, really helping to better understand astronomy. So look forward to seeing more, but it's a really exciting accomplishment. Understanding the small objects in our solar system. Now, we've previously sent a few missions to some of the various small planets in our solar system. And by small planets, I mean any kind of asteroids or comets or whatever. But during this decade, we were able to increase our knowledge so much. Between the Dawn mission orbiting Ceres and Vesta to asteroids, the largest asteroids in the asteroid belt, to the Rosetta mission going and understanding comets much better, including landing an object on there, to the New Horizons mission that flew by Pluto and then by a Kuiper Belt object, we're able to better understand all of these different objects and For the first time, we're really able to understand what's the vast majority of the number of objects in our solar system, these small asteroids and comets that are everywhere. It's amazing that we're really starting to understand these things because these are the building blocks of the solar system, and as we better understand them, we can better understand how Earth came to be as a planet. Hopefully we'll be able to get a lot more in this coming decade as well. Gravity wave detection. Now, this is just astounding to me that we were able to do this. This is something that Einstein predicted when he did his general theory of relativity many, many years ago. And it's always been in the theoretical realm, something that maybe we could theoretically detect, but we've never been able to really do it. Well, this decade, we were able to really positively identify these gravity waves by taking a very long, about 4 or 5 kilometers, something like that, tunnel, and very, very carefully measuring 2 mirrors. And if a gravity wave came through, they'd pull one of the mirrors forward, and we could actually see this wave propagate through. Not only were we able to make a detection, we're starting to make them regularly now as the equipment has gotten better. We're able to pinpoint where they are in the sky and be able to really advance our knowledge of some of the large objects in our galaxy. It's really neat that we're able to start understanding these objects, and gravity waves has some enormous potential. We could potentially see the very beginning of the universe in gravity waves better than we could in any other form, or even beyond the beginning of the universe. It has some really exciting potential, and hopefully we'll see a lot more of that in the coming decade. The privatization of deep space. Now, this may come as a little bit of a surprise to you, but during this last decade, we were able to finally iron out some of the details on how we can privatize deep space. You see, up until today, all of the private satellites that have been in existence have orbited Earth really not much further than the geostationary orbit belt that goes around the Earth. And with one exception, which did a flyby of the moon to try to change its orbit and was able to successfully do so to get to the geostationary orbit, it wasn't put in the right orbit. We had never sent anything into deep space. Well, that has changed. This little lander, the Beresheet lander, attempted to land on the moon, and granted, it didn't have the best go out of it. It did a hard landing onto the surface of the moon. But they were able to set in motion the way to legally go and send missions to deep space. You see, the Outer Space Treaty that was signed a long time ago says that the host country needs to be able to monitor all of the activities of the non-governmental states inside of it when it comes to deep space exploration. Well, that has never really been put to test until this decade with the Beresheet lander landing on the moon. And when SpaceX or some other private company manages to successfully land on the moon or Mars, they'll have in large part a thanks due to this little lander from Israel that crash landed into the surface of the moon to thank for it, because they paved the way for legally exploring deep space by a commercial entity. So I look forward to seeing more out of this stuff, and there's so many different opportunities in this coming decade to privatizing deep space. Even SpaceX was talking of sending their Crew Dragon to the surface of Mars, and granted that didn't end up happening because the way that Crew Dragon was going to land changed, but they're still talking about going and exploring Mars, and it is amazing to start to see this stuff really explode. Once we start to privatize deep space, we can start to do things like mining asteroids, getting resources from all over our solar system, which there's so many, and make our lives better here on Earth. We can even start to build habitats out of them and start to colonize space as we have objects to go visit. So it's a really exciting time to see this kind of stuff come to fruition, and I look forward to seeing more. I'm sure there's a few of you out there who are probably yelling at me for not including something to do with SpaceX. Well, I'm lumping it all together. The number one thing in the 2010s to change space and space exploration in my mind is the rise of SpaceX as a company. SpaceX in the beginning of the 2010s was just this tiny company that really didn't have a lot of history. They had attempted to launch a few launches on a Falcon 1 rocket that had happened in the middle of the Pacific Ocean. They had 5 launch attempts, 3 of which failed, one of which had a test payload and successfully orbited, and one of which had an actual real satellite, and that's all they had done. They had a contract with NASA to bring cargo to the International Space Station, which they were making a lot of progress on and building a much larger rocket. They had a launch manifest as they promised to reduce the cost of space, but they hadn't really accomplished a whole lot. Well, they have now. SpaceX has managed to bring back launches to the United States. You see, in the early parts of the 20-aughts, companies just didn't launch from the United States. Sure, the government did, sure, NASA did, but nobody else did because it was just too expensive. They would go to launch with ESA down with the Ariane rockets down in South America where their launch site is, or they would launch with a Russian rocket. These were much, much cheaper options, and quite frankly, a change didn't seem likely on the atmosphere. We were still building the satellites in the United States, but we were shipping them out to other countries to launch them. Well, SpaceX has changed that by reducing the cost of access to space. They did that by building all of their components in-house, so they had one rocket essentially built completely by them. That managed to reduce a lot of the costs, and they started to iteratively improve them. They've done things like landing a first stage booster and reusing it, stuff that, quite frankly, in the 2012 timeframe, people were mocking SpaceX as a company for even considering that as an option. But now they're able to do it quite regularly, and it's been able to reduce their launch costs even further than they had before. And they continue to innovate. They launched the largest privately funded rocket of all time, the Falcon Heavy, carrying a Tesla Roadster and a Starman to orbit Earth for a little while and then to be sent out beyond the orbit of Mars. That's something that just simply hasn't been done before, and it managed to excite the people into space. Many people who are not space nerds like myself and you guys were watching the launch of the Falcon Heavy and were inspired by it in ways that we haven't seen, quite frankly, since the Apollo program. Furthermore, SpaceX has continued to excite the public by actually proposing real missions to Mars with real payloads that can get us to the red planet. I'd kind of given up that that was going to happen. NASA keeps having this plan to do it in, maybe 15, 20 years. But SpaceX has a plan to do it in just a few years, and they're actually on target so far to meeting the original schedule that they proposed 3 or 4 years ago. Overall, the rise of this company has done a dramatic amount, and they've changed the landscape. Companies are starting to think of reuse. They're starting to think of going to other planets. We even have a competitor, Blue Origin, that while they haven't actually done anything per se, they have managed to build rockets and get contracts that should compete with SpaceX hopefully in these coming years. And there's some really exciting stuff that's happening. So it's been an amazing decade, the 2010s, for space exploration. I expect the 2020s to be even better. Thank you guys so much for all of your support. Let me know in the comments below if you think that I got something out of order or if there was something that I missed. I'd look forward to hearing what you guys have to say. Your comments are a big part of why I do this, to talk with you guys and learn what you guys are interested in. This next decade promises to be a very exciting time for space exploration. And I'm going to do a whole video about some of the major milestones I expect to happen in the 2020s that are going to really revolutionize how we think about space exploration. But to be honest, the things on this list, I don't know how many of them I would have predicted at the beginning of the decade. So we'll see how things go. But thank you guys so much for everything. Thank you for all of you who like and subscribe and watch all of my videos, who comment on them, who support me on Patreon so I can upgrade all of my equipment here, who come to my Discord that you can find a link below, that help me to hash out some of these ideas. You guys are amazing. I really love the community that's being formed here. Until next time, keep on tracking. Take care.